we will solve it using all the knowledge you've acquired up until this point. And this exercise will be solved by one of you guys after we are done with this. Okay, so this is the exercise we'll be working with throughout the course, and we are going to try to solve it without importing any module. So I don't think I have to read the question, but I'll read it again just for the sake of the class. So 10 beds are with equal width and length of 5,000 centimeters are subjected to flow indicated in the black arrow. I didn't include the image here, but if you need a reference, this is what we are talking about. So in this picture, there are 3 beds, but in the exercise, we are saying there are 10 of these beds. And the length and the width are the same with a size of 5,000 centimeters. And they are subjected to flow. Think of it like they've injected pipes into these beds and they are flowing water through them. So think of it like that. And the beds are basically rocks or sand. So think of sands packed on top of each other. Sands have a property we call permeability. So as the name suggests, how permeable the sands are to flow, how much they allow fluid to flow through them. If the permeability is high, fluid can flow through them easily. If it is low, fluid flow through them less easily. So we are supposed to calculate the average permeability of the entire system. We've been given the permeability of each of the beds and also the heights of the beds. To calculate the average permeability of the system is basically calculating the arithmetic mean. This is not the weighted mean. So this is the formula. We find the products of the height and permeability of each layer, and then we find the sum. We divide that by the sum of all the heights, and that will give us the average permeability. Okay. If please don't, yeah, I shared the notebook to 2 other people who will be solving the exercise. Please, if you are editing this, I'll be seeing it here. So please don't edit this notebook. Okay. Alright. So we are going to solve this, and then after we've calculated the average permeability, we calculate the flow through the system, and this is just the equation. Alright. Let's begin. So we need the heights and permeabilities in memory, so we have to create variables for those, and we learned that we can store all these variables as a list. So we will do that, and since they are in progression, we can use range to generate these lists. So let's generate the height with range. So the first value is 1,000. The last value is 1,500, and then the step is, as you can see, the difference is 500. Like we talked about the last time, the ending value is always exclusive, so we add the step to it so that the value will be included in the list. So this should be updated to 6,000. We do the same for the permeability as well. So we will do that without, I'm not going to type this out manually, I'm just going to use the range. So range 50. Let me zoom in a bit so that it's a bit clear. I think that this is fine. 50, 5. You're supposed to end at 550 and then 50. Okay, so we just generated this. Again, there are multiple ways you could have done it. You could have used list comprehensions if you are comfortable with that. So basically the same thing here. So instead of just using the range at once, you could have used the second line. So if you want to use this comprehension, you are free to do so. And then the third one that we went through by converting the entire range into a list. If you wanted to see the list externally, you could pass that into a list, and you could generate it. So these are the three types of list generation that we learned during the previous classes. I'm just going to stick with the first one. You can use any one that you prefer. Okay, so I'm going to add a comment here since we learned about comments. So all right. So now that we have the height and then the what do you call it? The permeability is generated. Now we need to find the products of these two lists. Um, how do we do that? So I'm going to introduce you to a global function called zip function. So without me talking too much, this is it in action. So I'll call the zip and then I'll pass the two lists that we have. I'm going to wrap this inside a list so that we'll see what it generated externally. It works like the range, so the list that it will generate will not be, it will be internal. So for us to see the list that it will generate, I will pass the zip inside the list function. So if you run that, so as you can see, we have the first column corresponding to the permeability, and then the second column corresponding to the height. So all the zip does is what's the word I'll use? Aggregates the list together to make a column list. So if you see how a zip works on your clothes, if you move up a zip, it will just align the two sections of the clothes together. So basically, that's what the zip function does. We need the two lists that we generated in the global list so that we can use list comprehension to multiply each of the individual elements because we need the products like the equation says. So let's store this let me call this kh in this variable. Then we run it. Alright. So now with this, we can find the products of, or let me just print it so that we can have that in view. Sorry for the sniff and stuff. I'm not feeling. So we have I'll not use the print. Let me just use so that we can see it. Let's see it. Okay. So we have a list that has each of the heights and permeabilities as members. So all we have to do to multiply each of the members is to use the list comprehension. So x times y. I'm assigning x to the k and y to the h for x comma y in kh. So if you understand your list comprehensions, this shouldn't be foreign to you. All this is saying is that for each of the elements in kh, so for each pair in kh, which we are designating as x and y, find the product of those two pairs and put them inside the list. So if you do that, this is what we get. So you can verify that 50 times 1000 is 5000 and 100 times 15,000 is 150,000 and so on. So we have our our product. So all that we have to do to find the sum, we just use the global sum function that we learned in the previous lecture. I already used kh, so what variable should I use for this? Let me just say kh sum. Yeah. So we'll find the sum of this list by passing the list inside um, the sum function, and then we can print the value of the sum to get what we get. Good. So we are halfway through. We just calculated the sum of the products of k and h. Now we need to find the sum of the heights, which is very easy to do. So h sum will just be the sum of the hi. Now we can print that because we already have hi here. We can print the sum of hi, and this is the value that we have. So then we can now calculate the average variability easily by dividing the sum of the kh over the sum of the h, and now we can print the average of the average variability of the entire system. Is that good? Any question? Okay, it seems we all understand where we are. Alright, so with that, we've been able to do the first part of the question. Now we just need to calculate the flow rate, which is very straightforward. So the area will be the width times the height.
So please, I wanted to ask a question with the zip function.
Yes.
In situations where you append or you mutate your list, like remove or maybe replace an index with a particular value in the list, can you still apply the zip function? And then my second question is when the index of the list is not equal, like the two lists are not equal. Maybe the first list has a total index or count of 20, and the second list has a count of 19, and you want to zip it. Can you do that?
Yeah. So the second question is straightforward. You can't, because if, for example, let's try this. All right. So let me say, uh, what can I use? You can't, but I just want to demonstrate so that you see. This
Maybe
is
A is equal to,
something like this, and then B is
yes, please.
probably something like this, and
Yes,
then we want to zip. Just put this in the
yes.
distance once. A comma B. Interesting. Is this okay? I did this before and I got an error. So what it did was it skips the 5.
Replace,
Yes.
yes.
So it appended the 1 and the 1 and the 3 and the 4, and because there's no other value to zip the 5 with, it skipped that and it ended.
So that means whenever we have like two lists that are not of equal indexes or equal counts, we must replace the last one or the other one with zero.
Not necessarily. If, for example, this outcome here, if this is the outcome you desire, so if you think that um, the ones that will not end up with any pair can be discarded, then you can still do this without putting any zero. because zero is a number. If your list that you're going to work with doesn't include zero, you shouldn't put zero there. I don't know if you get what
Yeah.
I mean.
Yes,
Yeah.
please.
So um, al-
Wow.
always
And
experiment.
then
Yeah. And there's
and
first
then
question.
please my next question, my first question that I asked about the appending list.
Yeah. So you said,
Maybe when you append, maybe we append a list to list A,
hmm,
and then we append a list to list B
yeah,
or a value or something. Can we still use the zip function?
yeah, you can. So when you append, for example, let me just do. So let's say a equals a dot append. Let's say 8 and 9, and then b equals b dot. Let me just take up this append value 3 1 4. So in this case, if you are confused by this, I'm using the same variable names. If you shouldn't be confused by this. So what this means is, first of all, Python just creates these three lists in memory and assigns these variables to them, A and B. So these two lists, I'm now appending this extra list onto it, and I'm assigning the same number, the same variable name to it again. So that's just what that
Okay.
means. Yeah. So
Mhm.
now I can still zip these two after appending. See. Okay. Let me print A and B and let's see what. Hmm. Why am I getting none? Alright. So and the list functions that we said the modify lists, those modifications are done on the list themselves. So what you are seeing here, a dot append, is the modification, is the changes we are doing. So we are basically saying we are assigning a variable to the change. So this is not saying we are assigning a variable to the list after it has been changed. The append is the modification. So we are saying that we are giving a variable name to the modification we are making to the variable A. That is why it's giving us none. The modification doesn't have any data type. So we are
So
just,
say you mean whenever we are mutating a list, we cannot define it.
we cannot assign it to anything else.
Yeah, we
So
cannot define it.
yeah, so something like this. With this, we shouldn't have any problem with this. So
Okay, okay.
yeah. So
Thank you very much.
if we print this, yeah. So this is the first two lists. This is A and B that we have here, and then this is the zip that we did. So after appending, you can still zip because the resulting um, data that you get after appending is to the list. So you still get the zip after you append. Yeah, yeah. So
But
yes, thank
I
you
see
for that.
that. So you can see that it has appended five with the whole list of B.
Yes. So the elements here, this 8 and 9 is an object because we are separating the entire 8 and 9. You can see that it is in between close brackets. So that is just a list.
Mm.
These are not individual numbers. This entire thing is the list. because
Wow.
because we are appending a list onto, we are not joining it. We learned how to join two lists, but
You're
because we are
using
appending a list, this is basically an entire object on its own. So that is what it did by,
so Python recognize it as
yes,
one
as
of.
one object. Yeah.
Okay. Thank you very much, sir.
Sure, you're welcome. So where were we? I don't know where we. Okay. So we were trying to calculate the this part. The A is just the width times the height. So we have the width, which is 5,000, and then the height we have the sum of the height has been calculated. Another parameter we need is the pressure, the viscosity, and also the length. So I'm just going to go ahead, and they've all been provided. So I'm just going to go ahead and type them out. Then we can calculate the Q by using uh, the equation that we have here. And we've already calculated the K average um, here. So we can just use that inside the equation. And now if you run that, we have our salt. It's supposed to be equal. Okay. Um, where did I do the mistake? Okay. Alright, so this is the fluid that we just calculated. So we learned about zip and how to use zip in list comprehensions, and we also learned about thanks to Stephanie's question, we learned about assigning variable names to modifications, which we shouldn't do. All right, so that is it for today, and I think um, Stephanie is ready to take us through how we'll solve this question. So it's basically the same question, but a few changes here and there. So before I hand over, please, does anyone have any question? Any question at all? All right, then we have about 30 minutes. So Stephanie, please take us through the exercise so that we will all see your thought process and how you did it.
So please, should I start solve it again with us, or I should show them
Yeah,
my solve?
yeah, solve it again with us.
Yes, please. Okay. So please, can you see my screen? Please, can you see my screen? Please, I would like you to talk because I'm using the whole. I'm coming to use the whole screen, or like this is okay. Alright. Okay, so please, let's read the question and kindly solve the exercise. So three beds with equal width and length of 5,000 centimeters subjected to flow, indicated by the black arrow in the figure below. So there's the flow. What is the average permeability, the K average of the system? So they've given us the equation and they've given us the flow rate with the other um, values that we'll need in solving for our flow rate. So looking at the um, K average formula, we know that we need permeability and thickness, and these are the permeability and thickness that we've given for the various beds. So we are going to solve this using our normal code, our models, without implementing or importing any Python model. So So we first calculate for the average permeability. And before that, we need to list our values for K and H, right? And then we realize that we can only use the range function or the list comprehension if our list has a common difference. With this, the list does not have a common difference, so we just list it as it is. So ki is ki comma hi. So now we've been able to zip it into x and y. So now the next thing you're supposed to do is to multiply. So we are using the equation as it is. Let's solve it as it is on with the equation. So with this, we are multiplying ki before we sum it, right? So we can use the zip function to aggregate our ki and hi values into x and y. So right now we've done that, which is the zip function we used. So with the multiplication of the KIHI values in the list, in the
Hmm?
zip list, we are going to use
Entry.
the list comprehension,
Entry. Sir.
right? So
And
let me do that as KI underscore HI.
total fees.
So for every multiply KI HI
Interest.
for KI comma HI in our zip list that we have above. So we've been able to multiply it. So then we move quickly to calculating for the average permeability. So K average will be equal to sum of this Ki value that we multiplied for the zip function. Please, are you guys following? If you don't understand, please you can ask me questions so that
Yeah,
we all.
I have a question.
Yes, please.
With the list comprehension, um, the zip, the name that you give to the zip is different from the name that you're using inside the list comprehension. So you see that the zip is small ki, but the one you're using here is the capital Ki. Why?
Yes, please. Thank you very much. So with this, we've been able to um, calculate the if I'm to print this. Okay, so if I'm to print this, you can see the value of the K average, which is 400 MD. I can also assign a string to it. From the other this one solution, you realize that our colleague also used the string functions to define the in order for us to understand what we are calculating. But we all know what we are calculating here. That is the K average. So there's the value. So I don't want to like open a different like code this one. I want to continue. So let's continue with this. So our next thing is to calculate for our flow rate. So calculating for the flow rate, we need to define some variables in the equation. So we have our K average, and then for area, the area is the width times the sum of the HIs. So we are going to define the area as well, which is the width is 5,000 times the sum of HI. And then we are going to define the other variables, which is P2, P1, mu and L. So from our question, P2 was given, P1 was given. So P2 is 1,990, and then P1 is 2,000. Then we have our mu, which is 2 centipoise, and then the length, which is 5,000 centimeters. So moving on to calculate for the flow rate, which is Q. Q is equal to negative 0.001127 times our K average times our area, which is A, times P2
Yeah.
minus P1,
Oh, one.
right? All on mu times L. Yeah. So please, I'm done. Please, do you guys understand what I did here?
Yeah. So yes, thank you very much. You explained your thoughts and you corrected your errors, and I'm happy that you are able to do so. Thank you. Please, if you have any questions, she's ready to answer them. And I think this will be something I'll be doing from henceforth. So the next session, Latifa, I know, um, fine, no worries. But Latifa, next session you'll be the one solving the question. I hope it will not be any pressure for you. And the next one too, I'll call on somebody else. But thank you, Stephanie, for your contribution. You've done well. Thank you.
All right, thank you very much, sir.
Okay, so let me take over and share my screen and show you what we'll be doing on Thursday. So on Thursday we'll be done with half um of the cohort because there are 12 sessions in all.
Wow.
Is that too much?
No, please.
Before this session will be over, you will see how much you would have improved with this free cohort. It's not really anything, but just because of exercises, you'll be able to write your own programs on your own. And you're even doing so on your own already. So this is what we'll be
Yeah.
doing in the sixth session. We will be talking about branching. So we'll be doing some things like this: yes or no, greater than or less than. So basically about branching, or what the Python programmers will call if-else statements. And we'll be solving some um, quadratic equations, and I'll be giving you an exercise where you write a program that will predict whether a solution is acidic or neutral or basic. Alright, so that is it. We will continue from here
Wow.
on Thursday. And don't
Yes,
worry,
yes.
I'll be sharing the notebook in the group as well. I won't forget.
Yes, yes.
Alright,
Thank you very much.
yeah. Alright, so thank you, Stephanie. Thank you, everyone, for joining. I appreciate your commitment. I'll see you guys on Thursday.